So we have this rectangle. The lengths are A and B. We'll call this length A. We'll call this length B. So if I come over here, then A is this short length, and then B would be the length going from point A to point B up there. They're different variables because we're using the lowercase letters. B is the entire one, A is that short one, and then the other thing we have is we're going to say that this length right here is going to be little c. We have to find x so that A times B is equal to C times x. That would make it so that those areas are equal. And we're going to use the example from section 2A. And if you remember from that section, all three of these points were on that same circle. So what we're going to do is figure out where is the circle that has all three of those points on it. If there's any three non-collinear points, there's always one circle that contains all of them. And to find that, we'll construct this triangle. Then we'll construct the midpoints of all of those sides. And then I'll take just one of these midpoints, point N, and we're going to construct a perpendicular bisector. Because the intersection of the perpendicular bisectors is going to be the circumcenter. It's going to be the center of the circle that we're looking for. So one more time, take this midpoint and construct another perpendicular bisector. So where these two perpendicular bisectors intersect, that's going to be the center of the circle that we're looking for. Clean this up a little bit, hide those lines. From here to any one of those points, point A, we can construct the circle by center and point. And again, I'll clean this up a little bit more. Hide those. You see that points C, J, and A are all on this circle. So A times B is equal to C times X. So if I put this point over here, I should be able to get this thing to work out. So I already measured CB times AB, and that's that length. And I'll measure this length. And then we can measure the length from B to P. And then we will calculate the length of BP times the length of JB. And as you notice, those two are the same. I can drag some of these points around a little bit. You'll notice that the size of the rectangle changes as well. All the numbers that are changing, but what's significant is that these two products are all going to stay the same. So if I make a rectangle that has the length of C and this big length of X, I know that those two areas are always going to be the same. So that uses the principle from before, that when you have a point outside of a circle, draw in two secants, then the length from this point to the circle multiplied by the distance from this to the other side of the circle is equal to the other product, BJ times BP.